Lieutenant Governor, are you with us?
I'm with you.
Awesome. I'm Jeff Stacklin. I'm the Director of Communications here at Perkins Schools. This is our robotics club.
Hello, Robotics Club. So you did some pretty awesome things, I understand, and you're going to have your technology on a NASA flight. Is that right?
Yep.
Well, tell me about it. Can you? I'm reading about it, and I know that I won't understand it until I see it in action. You're going to show me what you have there?
Noah, step up. No.
By the way, did you know Paolo DeMaria, the State Superintendent of Schools, is also on the call? Can you see him there?
Good to see everybody.
Yes.
Great.
So step on up, guys. Come on to the program.
So I'm Noah Brodkey.
And I'm Evan Gilchrist.
And so we got to make a CubeSat, and it's like a mini satellite. It's about that size. It's 4 by 4 by 12 inches. And so inside of that is going to be like a robot arm, which is what we're thinking of now, but we could change our idea in the future. And it's going to be able to pick stuff up, place it like different areas, and there's going to be a camera so you can see. And it's instead of just metal, it's going to be plexiglass, so you can see through it, and that's going to be able to add more complexity to it, because when there's the sun, it's going to glare and it's going to be harder for you to see stuff. So.
And so where give me the practical use of what you think it's going to do. Like, give me an example.
So if a satellite in space, like in the future, if NASA takes this up, a robot arm in space could go to satellites and repair them instead of manually going out there or having to destroy them and then send a new one up.
And have you tested that on a device like a satellite yet?
No, we haven't. This is like a proof of concept.
Yeah, it's proof of concept. Got it. And so as I look at this, you're out of 11 winners, you went up against MIT, like the University of Colorado, and a lot of big schools with college students and your high school students. How's that make you feel?
Pretty good.
Did you convince your school to simultaneously offer you college diplomas as well as your high school ones when you graduate, since you're beating college students?
Not yet.
Yeah.
But it sounds like a good idea, huh?
Yeah.
So, Superintendent DeMaria, do you have any questions for them?
Yeah. So I'm curious about, like, what will you learn, and will you get data back? I'm always curious about these small satellites, because I think it's fascinating, because it gives NASA the ability to put lots of like little science experiments in space. But will there be a way for you to get data back about whether it's performing the way you expect it to, that then allow you to modify your proof of concept?
Yeah. So there's going to be a radio on it that's attached to the top, and we can communicate through that radio from a website that we're going to be making, and it's going to go to a bunch of different satellites, and then all of those satellites communicate to our satellite. So, and we can send and receive data from it.
How did you know what, in other words, what boggles my mind is, you probably read somewhere NASA put out a set of specifications or whatever. How did you know what you could do, or what you could fit into a little cube like that? Everything from the communications capability that it has to have to, the mechanics around the robotic arm. Where did that knowledge come from?
School, like they give you specifications for like the sizing and stuff.
Yeah.
And you can go off of that So like you can see other arms,
Yeah.
and you can use those to like mock up something, and then you can just downsize it. You can use CAD, which is like you can draw stuff up on a computer for software, so you can kind of get a visualization of it for yourself before you can put it into use, and then you can build it to prove it.
And you're going to be able to test then how you can manipulate that robotic arm to take different actions from the ground while it's in space, in this idea of being able to show that it could be used to repair satellites or something like that.
Yes.
Yeah, well, that's incredible. It's incredible. I think I also gave you an opportunity to say, I have really great advisors helping us out. Do you want to say something about the advisors for your robotics team?
So we're a small company here around the area that does some technologies, and our hope in helping Perkins put together this proposal, being in the Erie County District, is to harness young minds and then have them potentially come work for us. So keeping people with good talents in this area is one of our goals. So Dr. Walker and one of his affiliates helped Perkins put together the proposal. They've launched a few CubeSats in their times, and they're looking at some CubeSats with some of the other NASA agencies for Earth observing and other applications. So they help kind of put this together, and they've been part of the advisory team.
Right, and I'm actually a Perkins alumni myself, and we've got some other Perkins alumni who are on
Nice.
our mentors, and we're just creating that pipeline from the students right up through STEM educated employees.
So are you hiring any of these high school students as interns?
So Alex was actually an intern for me. He started out right out of high school, started college. We put him through basically all the way up to his PhD. Again, hoping that this kind of continues. We've been growing as a small company, larger and larger. So our hope is to continually do the same thing.
And now we've got Merrick here, who is Noah's brother, who is also going to be interning at Sierra Logo in the near future. So we have demonstrated pipeline of talent from Perkins High School up through the aerospace industry right in our local area.
That's great. So what haven't we asked you about that you want us to know that is a unique obstacle you overcame, something special about this, a funny story that happened along the way? What else would you want us to know?
I don't know.
You're a scientist, not a public speaker. Is that right? Is that what you're telling me?
Yeah.
So yeah, come on up and have others participate. I don't need to put you on the spot at the whole time.
Hi, my name is Brooke, and I haven't been part of this program for long, but I know that as someone who has just been kind of interested in just like building robots for a while, it's fun to come in here and be able to work with other people who know more than I do and get to learn from them and help them put this kind of stuff together. So it's really cool because you don't know what exactly you're going to do right at the beginning. When you finish it, you're like, wow, I made this. And it's really cool because you get to like see, wow, my brain actually functioned and was able to put this together with people that I didn't know that now I'm friends with. So you kind of just get to build yourself along the way.
Well, that's exactly right. That's a great perspective. And are any of you involved in, do you have a local Ramtech program, or any of you involved in that?
No.
No. Okay. You're your own program.
Yeah.
What's Ramtech? Just out of curiosity.
Robotics automation technology program. A lot of the career centers, there's about 25 of them across Ohio that help you earn industry credentials in robotics while you're still in high school. So credentialed programs.
That's good to know.
Yeah, thank you.
I would love something.
Well, if you're as the teachers, advisors, local private sector folks, if you're interested more in it, you can contact me or Superintendent DeMaria, and we can connect you with those things, because all of this great stuff you're doing. I'm sure we can translate that into industry certifications and college credits for you as well.
Be awesome.
Well, that's congratulations on earning this opportunity. What's the next big idea? Are you still working on perfecting this one?
Yeah, we have to work on this first.
Yeah. Seems like if you're going to be actually in space fixing satellites, it seems like you might have a little more work to do, right? I mean, you know, that's just it's pretty amazing that you've been able to do this. And I hope that it gives you all confidence to know that you can do anything. I mean, you're obviously you've learned so much from this experience, but you know, science and what you learn from these science opportunities, you know, you can change the trajectory of the world. So, and how people live and work and it's all, you know, you all have that capability. So what am I going to see here now?
So this is just a short demo of some of these are like larger arms and it's gonna be on the satellite, but it's gonna be similar technology that's running on the computers that's controlling these arms that'll be on the satellite. It's doing OHIO.
All right.
So that may not look like a whole lot, but that is a massive step forward for us. Just being able to utilize technology in that way and control them to that manner.
And so, are you program them to do that. And now you're going to turn OHIO into how do I find the specific thing on this satellite and how do I, you know, replace this or fix this or adjust this. Those are the kinds of that's the next step.
Yeah, my brother is actually the main developer of that code that runs on there.
It's clearly not a Wolverines fan. Well, that's great. What else would you like us to know?
I remember when I first came in, when this was a really small group of 2 or 3 the first year. And we kind of walked through what the robotics program was. We brought to Mr. Stout and his team almost like the life cycle of a satellite. Said, hey, what you guys are doing is the same thing NASA would do in building a satellite. Here's the steps. It's like a learning process. If you guys go into anything technical, you're going to be doing the same thing. And those same bits and pieces are what they use to do their basic robotics, and they're going to take that same life cycle thing, because what the ideas that Merrick has and the team have, we have to balance with that little box there and make sure that when we make it go wiggle and jiggle, that the satellite doesn't shoot out into space. So there's always a balance between them, and it's going to be a difficult thing, but it's I think an amazing learning process, because you got to go from step 1 to step 2 to step 3 all the way through to testing, like you said, to putting something out. And it's no different than what they're doing with the robot. It's just maybe a little more fun because it gets to go out in space. So
yeah, because the physics of how you repair something in space is much different than how you repair something in a gravity atmosphere. Who's your space expert on the team that understands zero gravity movement?
Us too.
Yeah. The Sierra Lobo vector, basically.
Well, I'm glad somebody understands it, because you wouldn't want to depend on me for that.
So again, it's a hope that, you know, we can harness some people to get excited and stay in this area, and, you know, hopefully work with us versus, you know, there's lots of exciting things to do out there. But
Yeah, well, congratulations. That's amazing. Well, thanks for spending a little bit of your day with me and Superintendent DeMaria. one of the things about my job is I get to meet basically people from all around the state of Ohio and sometimes the world. And there's nothing more inspiring to me than when I see Ohio high school or Ohio, students doing amazing things, because it gives me a lot of faith in you and the future of our nation. I'm very proud of you. Governor DeWine's very proud of you. Superintendent DeMaria is very proud of you. You're champions, and we're gonna share your story wherever we go. And I hope you'll keep me updated on your progress. Would you do that for me, like once every 6 months or so? Kind of let me know where things are and where you progress, so that I can continue to talk about how amazing all of you are.
Absolutely. Yep. Yeah. Appreciate your time.
Great, thank you.
Thank you. Thank you.
Keep up the great work. Keep up the great work.
Thank you.
Thank you.
Thank you.